Well, correct. All right, so 3-3. What area are we looking in here?
Like 185 or 195.
There we go. Oh, all right. Let's do this one. Let me see. We'll do 186 just because. Yeah. Someday. Two. Let's see if I can do this. There we go. All right. So last Saturday, the museum box office sold 281 tickets for a total of $39.54. Adult tickets cost that, blah, 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 blah. So what do you not know? That is problem.
How many of each type of
Yeah.
was sold?
And you can pretty much always look at the, where'd that come from? Is it yours? You can pretty much always look at the, thank you. Nobody went for it. I was like, oh my God. Look at the question. We don't know anything about how many of each kind, right? So I got the number of what tickets? Adult tickets. I like it. And the number of student tickets.
So 281.
Good. So one of them's got to be just X. You guys see how in this case it doesn't matter which one you call X because you don't know either one. So if I call the adult tickets X, what must the student tickets be? See if you guys can get this. How many total tickets were sold?
281.
281. So if I sold X adult tickets, how many student tickets did I sell?
281 minus X.
281 minus X. I think that's one point I said. If you ever have a total amount, if one's X, the other one is total minus X. If you don't believe me, if I sold 60 adult tickets, how many student tickets must I have sold?
60 minus X.
Come on, no. If I sold 281 total, right? Can't escape that. That's the truth. So if I did sell 60 adult tickets,
281 minus 60.
281 minus 60. If I sold 80 adult tickets, 281 minus 80. Well, how many adult tickets did I sell? X. So 281 minus X. I like it. Now your equation is going to deal with what idea? Is it going to deal with number of people? Is it going to deal with the length of banana peels? What's it going to deal with?
Total amount of 39.
Amount of ticket.
Yeah, it's going to deal with money. Yes?
Yes.
Isn't that the overriding thing about this? I know how much money total they made. So how much money did each adult ticket bring them? $15. So I sold X adult tickets. How much total money did I get from the adults? 15. And this is what you got to get over. So if I sold 10 adult tickets, how much money is that right there? 150. You with me? Adult tickets cost $15.
Oh, yeah.
So if I sold 10 adult tickets, that's 15 times 10, 150. Is everybody cool with what I just said? Now everybody says the minute you put variables in, everything changes. Nope, not a damn thing can change, because variables are numbers. They have to do the exact same thing. Doesn't matter that I said 10. Would you have done something different if I said 20 adult tickets? No. How do you figure out how much money if I sold 20 adult tickets? How much money is that? Each one costs 15, and I sell 20 of them. How much money is that? What do you do? 15 times 20. What if I said 30 adult tickets?
15 times 30.
Well, how many adult tickets did I sell? So how much money is that? 15 times X. That's how much money I made off the adults. Now, how much money do I make per student? $12 per student. How many students came?
281 minus X.
281 minus X. So $15 per this kind of ticket plus $12 per this kind of ticket gets me how much money total? $39.54. All right. And then the equation should be the easy step, solving that bad boy. You have to identify, and again, go to the question. That's where you start defining variables. Then how does the other information come into play? I got to make an equation about money. So number of tickets, now I got to multiply by money per ticket. That's money. Money, money, money. So the equation makes physical sense. It all comes off of this step, though. Skip that step and you're screwed for the most part. You don't know what it is you're working with. Okay?
Okay,
Yes?
180, the same section.
All right. Let's see. This thing is not built to handle much of anything. All right. Oh, do you see how this is the same exact problem? So you guys are like, no, it's not. It's got different numbers. No, I don't care about the numbers. Isn't this the same problem? If I knew how many child tickets and how many adult tickets, each child is $8, each adult is $12. It's the same. It's the same problem. Do you guys see that? It's a little bit nicer though, because what are my two things I don't know? What are the two things I don't know?
Each ticket's how
Each
much?
ticket. How many types of tickets are there? There's two of them, right? What are they? What are the two types of tickets? Say that 5 times. What are the two types of tickets?
Child tickets.
Child tickets. So the number of child tickets
And adult tickets.
and the number of adult tickets. Sounds like adult beverage. I don't know. All right. I really want you guys to understand. That's why the first step of a word problem is just write down in English what the parts are. Then give the parts math names. Right? It always starts at the same place. I can see the question is how many of each ticket. Okay, how many types of tickets? 2. All right, I need 2 things in English, child and adult. Now who's going to be just X? This one's a little more traditional, to be honest. The number of child tickets is 17 less than 3 times the number of adult tickets. So which one do I have to call X?
X equals 3y minus 11.
Stop.
No.
Is the child tickets X or is the adult tickets X? Why the adult tickets?
Oh,
Because the number of child tickets is 17 less than 20, the adults. So I got to know the adults first. You guys see what I'm saying? So again, do you notice almost every time we do a problem, except for a couple that have the table and kind of weird shit, but most of these word problems are English of what's going on, who's just X, write the other one based on that. So in this case, I gotta know the adults first, because now I can write 17 less than 3 times this. What's that gonna be? Yes, 17 less than 3 times that. I couldn't write this without calling this x first. And now you bring the money. Now I got to make an equation about money. And this is number of tickets. So how much do the adult tickets cost? $12. So how much money total did I make off the adults here? 12x. $12 per adult. I had x adults. So 12x. Plus, how much does each kid's ticket cost? $8 per ticket. How many tickets? And I made a total of $584. Blah, 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 blah. Yes.
And we're allowed to use calculators?
Yes. Yes. Calculators, I don't care. They're not going to help you with anything except the last step. So yeah, you can use them.
Exactly.
Yep. So go ahead and use them. The people that will do the worst are the people that will skip this step. You kind of see the algebra. 3x minus 17, okay, equals 584. So for this kind of problem, I always see somebody does this. Let's make it a little more. There it is. Right? Because they see 17 less than 3 times. Okay, that's this. 584, okay. What is this? This is number of tickets equals money. Okay, that's weird. Unless you're in some kind of post-apocalyptic world where instead of Nuka-Cola bottle caps, you have tickets as money. I don't know. Right? My Fallout people. Back when Fallout was good. All right. So I want to try to show you something here. Let's see. Anything else specific from homework stuff before I do something related? Don't write this down, that's bad. You got it? If I said there are 5 less than twice as many kids as adults. Okay, that's kind of worded strange, but we're going to work with it. 5 less than twice as many kids as adults. Actually, you sometimes see a word like this, but let's see if you guys... Right there, can you write expressions for the number of kids, number of adults? Can somebody see how to parse that? What's going to be just X?
3 adults.
Yeah, why? 5 less than twice as many, careful, 5 less than twice as many kids as adults. Yeah, so if there's X adults, there's 5 less than twice as many kids. So you're going to call the adults X. What's the kids going to be?
-5.
Okay, good, I like it. Do you see how I haven't said anything about what these two do yet? If I said the total number, so let's see. If I said the total number of people was, what, Jeff? I don't know, Jeff. Come up with something, Jeff. 25. What equation would you set up? If I said the total number of people is 25. This isn't crazy, right? Total number of people. Kids are people, adults are people, right? So what would the equation be? Yeah, if I add the adults to the kids, I get 25. Is that cool? So x plus 2x minus 5, 25. 3x equals 30, x is 10, right? So then 2 times 10 minus 5 would be 15. So 10 adults, 15 kids. All right, blah, blah, blah. All right. What if instead the rest of the problem said kids cost $5, adults cost $15. And we made, I don't know, Jeff, what? We made, you can do it, buddy. Oh shit, why did I pick that? Just because. Oh, let's make it, I like it. $200. Right, so the first part of the question is this. The next part of the question could be this, which leads to this equation. The next part of this question could be this. Does it change this? No. The number of people, that's what it is. And then this tells me how they relate to each other. What equation would I set up from here now? We've done a few of these in a row. Kids cost $5, adults cost $15. So how much money did I make off the adults?
15.
No, that would be if I had one adult. I would make $15, right? Do you guys get that part right there? If there were two adults, how much money would I make off the adults?
30.
$30. Everybody see that?
Yeah.
Everybody cool? How many adults were there?
2. Hold on.
How many adults were there?
X.
X. So how much total money did I make off of them?
15.
15 times X. This is what I mean when I say variables have to do the same thing that numbers do. Because they represent numbers. That's what they are. They have to do the exact same damn thing. So if you give yourself a couple of numbers, what if the adults was 7? How much money would be 7 times 15? What if it was 8? 8 times 15? Oh, it's 15x. That's how much money I get from the adults, 15x. How much money do I get from the kids?
2x.
That's how many kids there were. Per kid I made $5. So if there were 10 kids, I would have made how much total money off the kids? 50, right? Do you guys get that piece? $5 per kid. 10 kids, $50. You ain't got no money, kid, go get a job. Right? Yes, yes. What if there were 20 kids? How much money would I make off of them? If there were 20 kids, $100, right? 20 times 5? Is that cool?
Yes.
How many kids were there? This is where you kind of lose it. Don't say you don't know. We do know. There were this many.
2.
There were 2x minus 5 kids. So how much money did I make off of them? 5 times how many kids there were. That's the part that's really hard for people to get over. That's what algebra does for us. We don't have a frickin' clue, but we sort of pretend like we do for a minute. I really want you to see that. And once you see that, I want you to realize it's not just because we're making shit up, but it's so I know what the hell to do with this. If I knew how many kids there were, I would multiply by 5. I wrote down in Mathish how many kids there were, so I'm going to multiply by 5. That's what I would do. And how much total money did I make? $200. Same thing here, different equations because I had different relationships, right? And then whatever the hell that is. Yes?
I don't know if I downloaded that, say after.
Oh yeah, all right. I kind of got it.
Sorry.
So this was 10, right? And 10 was adults. And so there would be 2 times 10 minus 5, 15 kids.
Oh, okay.
Yeah. And you check it, 10 and 15 is 25, yay.
Okay, thank you.
So if we solve this one, this should be the easy step. Can I skip a few steps? 15 plus 10. 5 times 5 is negative 25. 25x equals, add 25. Divide by 25. Right, like a normal person, Jeff. And you get 9. 9 what?
X.
X is 9, which means there were 9 adults. And how many kids?
2 times 9 minus 5.
Say again? Yeah, 2 times 9, so the 2 times 9 minus 5, 18 minus 5 is 13 kids. All right, my point for this is what I mean by the first step. You just care about what is it you don't know in English, give them math names. I don't give a shit how they relate until I get this done. The equation comes from how they relate to each other. Maybe. And if you have an equation that's supposed to equal money, then all the parts of it better be money. I can't have ticket plus ticket equals money. Can't do that. Yes?
So from the equation, when it was if the kids' tickets were $5, you take the number with the 2x minus 5, and you put it back into the equation.
No, you haven't made an equation yet. So if the kids cost $5 a piece, and if I knew how many kids there were, I would multiply, wouldn't I?
Yes.
Here's the part of algebra you have to get over. I do know how many. I know exactly how many kids there were. There were 2x minus 5 kids. I say it like that because then I do what I would do. If I knew how many kids there were, I'd multiply by 5. Well, I do know how many kids there were, so I'm going to multiply by 5. You guys are able to do that when I give you numbers. 2x minus 5 is a number. So you do the same thing with it. Okay, I'll stop. Anything else specific from the homework or anything? I want to get it. Okay. So just I'm surprised nobody's asking about this, but a few people have done the homework. You got a couple of equations they give you. I call this the I be pretty equation. I equals PRT. This is for simple interest off of some, with some interest rate. P is the principal, the amount of money you put in. T is the amount of time in years normally. All right, so you have a few equations where it's just plug and chug. That's nice.
What is principal, rate, and time?
Yeah, principal, rate, and time.
Okay.
Yep.
I learned that from, what is it, tutor. that used to
Oh,
talk
good.
about that, yeah.
You should also learn from the homework in the book. And they could always ask me, but nobody did. But I wanted to bring it up because nobody asked me. I wanted to. So if I had a 4.7% rate, what number would I use in the equation? I'm not going to put 4.7 in there.
The interest.
0.0.
Say again?
0.0.
Yeah, it would be point, yeah.
0.047, yes. You got to move it back twice, right? Is that cool? I think I heard it, and I wasn't sure. It was all very soft. All right. It's like when I grade homework, I love it when I see a part where somebody's not sure, the pencil writing is really light for a minute. And then it comes in hard on the chorus. I understand. Okay, so there is an equation like this in the homework, and it's just a plug and chug thing. You just put in there the amounts that they tell you. You just have to know where to plug it. Okay. All right, if there's no other questions, we're actually going to do a little bit into the next chapter because we're crazy. Okay, I like it. We spent a whole week on word problems. I think it's time to move on. Well, all word problems have numbers.
Other numbers.
All right. So chapter, what the hell is that? I can't remember. 4, yeah. It's all about graphing. Graphing is normally not hated as much as word problems, right? But it's still kind of up there on people's hatred lists. Which I kind of, so okay, let me do it like this. I want to kind of bring in to play the things you got to know, the basics, but I want to do it in a little bit different way. If I said, what is the answer to this? You could tell me exactly what the answer is, right? What's the answer to that? Yeah. Yeah, it's 4, right? So -1, -1. X is 4. Right? Could you graph that? Yes, you could. Believe it or not. 4. There it is. Right? There's no greater than less than. I don't got any shading. Are you with me? So I would really not even graph the damn thing. There's no real point to it. You with me? That's not like a pun. Point. So watch this. What we're about to get into then involves more than just one variable. Can somebody tell me, give me one answer to this? What are the answers going to have to consist of? I can't just say 7. What? The answer has to have how many parts? 2 parts. Why? Because there are 2 unknowns. So an answer is actually going to consist of 2 parts, but it's still an answer. Can somebody give me one answer? 1 and 4, I think is what you said, right? I'm going to make that up because I think that's what you said. So I represent it like this. Is that cool with everybody? So X would be 1, Y would be 4. That is an answer to that, isn't it? Give me another one. 5 and 0. 2 and 3, 3 and 2. I like it, all right? How long could you do this?
Forever.
Freaking ever, and you haven't even cracked past whole numbers. Right? I could also do 7 and -2. Yes? There's some integers. How about 5.5 and -0.5?
Yes.
What about 0.7864973921111113, comma, whatever the hell 5 minus that is? You gotta see what I'm saying? What's my point with this? This, when I ask you solve this, you can tell me what the answer is. You don't need any visual help. I really want you to understand why we graph things. So why the shit do we graph stuff? Because if I ask you to list the answers, it would take you the rest of your life, then you bequeath it to your kids, and they keep writing it, right? And then they bequeath it to their kids if they have time to make kids, because they're writing the damn answers the thing, right? You guys kind of with me? I mean, because it's an infinite number of freaking answers, holy shit. So much easier than that is to realize that if I graph these points and connect them, as I connect them, I run through all the other answers. Which is one of the main reasons why we graph things. Is because, so watch this. So this is going to lead to our first basic skill with graphing. How do I graph those? What do I make to graph those?
An X or Y.
X, Y. So I know the x-axis. We've used that already several times. We just throw on top of that a y-axis. Right? You've heard all the stuff about latitude, longitude, probably how that's like this and blah, blah, blah. Right? So it's just really locating something.
Similar to grids.
Grid, yeah, it's a grid. Has anybody ever been to Salt Lake City? Let's pick on Salt Lake. I went to see a friend of mine there one time, and it was just amazing. I'm not Mormon, so I always felt like everybody's like, you're not Mormon, but the streets are just perfect freaking grids. It was almost too much, even though I'm a math guy. I'm like, no, it's just too nice. So if I want to plot some of these points, I'm going to plot all of them. Let's just go up to 5. Yeah. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. -1, -4, Right? Hopefully this is familiar. So we did the x-axis. It kind of makes sense to put the y-axis perpendicular to that, have its own. So x is left and right, y is purely up and down. You could think of a third axis coming out of the board if you want to do 3-dimensional shit, but we're not going to do that. Don't worry. I'm going to stick with flat, right? So how would I plot the point 1, 4? What are they always in order of?
Positive.
Right, they're always in alphabetical order unless this problem says otherwise. So it's x, y. So I'm going to go 1 on the x, and then I'm going to go 4 in the y direction. So there's that one. Let's call that point A. How about 5, 0? Where's that going to be?
Five.
Yeah, so 5 on the x and none in the y, so I'm right there. Let's call that B. That's amazing, Jeff. So I'm going to keep going. 2, 3, 2, 3. Is everybody cool with this? I mean, I know some of us are really cool with this and some of us not so much. So If you're not so much, you're not alone. But I really want this basic idea to be, 2 in the x-axis, 3 in the y direction. That's 2, 3. 3, 2 would be 3 on the x and 2 in the y direction. Yeah, that's plenty. I think, I don't want to go 7, negative 2. I didn't really build it for that. So if my scale was really good, this would make a straight line. So I just make these bigger. Hey. Cool?
Cool.
And I could even see it's predicting there should be a point at 0, 5. Will there be a point at 0, 5? Yeah. 0 plus 5 is 5. I like it. Okay, cool. So if somebody said, tell me all the answers to this, I'm not going to do this because that misses an infinite number of answers. I'm going to draw this, put little arrows on the end and say, there's all the answers. I don't see mine. Yeah, you do. Just keep going, whatever direction. I ain't got time for your shit. All right? Maybe don't say that. I ain't got time for your shit. Look at my graph. All right. But you guys understand that's the most basic reason we graph anything. It's not the only reason, dear God. But it's the most basic reason is it's the quickest answer to the question. What are the answers to that equation? Look at the picture. So this point does not do what?
Intersect.
No, come on. What's true about every point on the line? Whatever this point, what does it do?
Oh.
It works in the equation. Whatever that point is, it works in the equation. So this point does not work in the equation. Right? So if I said, is 103, 99 on this line, let's say negative 9, on this line, would it be?
No,
Because why?
because there's a negative 99.
I don't care. That's okay. That's no problem. I'm actually one off from it
Our
working.
answer is 5.
Because when I plug 103 and negative 99 in, I don't get 5, I get 4. You guys with me? So to be on the line, it must solve this equation. If it solves this equation, then it's on the line. I like it, I like it, I like it. We're going to start with lines, obviously. Later we can start talking about curvy things. Curvy. Throw a ball, and what's it look like? It looks like a big ass parabola. Remember that? Don't worry. We're going to keep it straight for a while. All right. So, let me ask you this. While this is up here like this, what point is this? Even though you can't really... Yeah, don't try to make sense of what that symbol is. Negative 3, 0. I love it. What point is this?
0.
Say again, sorry?
0.
0, negative 4. I love it. Right? Kick ass. Not too bad. Okay. What's the first thing got to tell you left and right? So if there's a 0 somewhere, so if there's a 0 second, it doesn't go up and down at all.
Yeah,
Because the y is up and down.
yeah, I got it.
If there's a 0 in the first place, it doesn't move left and right.
Yeah.
Right? So anything that looks like this is going to be where? What axis will it be on? Anything that has a 0 in the second spot, it's going to be on the x or y?
X, Y.
It's going to be on the x-axis.
Oh, yeah.
X.
Because y tells you up and down. If it doesn't go up and down at all, it's on the x-axis. So what's anything on the y-axis tell you? It's going to be like this. Okay. It's going to come into play later.
Positive. This is 0 point some positive number. It's gonna be on Y.
Yeah, so if I said plot 0, 2,
Yes, it's gonna be on
0 means don't go left and right at all, only go up 2.
Up. Yes.
So that would be the point 0, 2.
Yeah.
Coolness. Like it. All right, so one last problem, and then I got a little handout for you guys. What you got, Chuck? Can you guys complete that table? Do you see how that's 3 problems up there? There's problem number 1, problem number 2, problem number 3. What does problem number 1 say? What's true about problem number 1? What's true in this one?
We put any number,
What's it say?
X and
X equals 0, and it doesn't know what Y is. But you know what the relationship is, right? So this is a relationship between X and Y. So if I know one of them, I have to be able to figure out the other one because I know the relationship, right? Right? If I know that you're half as old as I am, the minute you know either one of us, you should be able to work out the other person. Right? Yes? No?
No.
Yes.
No? What? All right, so what's the first row tell you? What do I know the value of? X. I know X is 0. So the first problem is put a 0 in for X.
Yes.
So what do you get when you do that? Do you see what I did? Why did I do that? Because what's the first row tell you? X is 0. What's it not know? It doesn't know what Y is. So what do you get for Y? Yeah, so then that goes here. So what point does that line go through? So far I know that it goes through 0, 9. What happened? I lost everybody. Shit. So I'm hoping most of us have seen an XY table like this. So each row, if I have something in that row, I know what that variable is. So here I know X is 0, I just don't know what Y is when X is 0. Well, when X is 0, Y is 9. Bam! So I know it goes through the point 0, 9.
So then would you plug it in the other?
So what happens here? What do I know here?
6 plus
Yes, you put a 6 in for Y.
What do you?